In this video, I'll be showing how to draw a hyperbola. First of all, let's have to find the range, domain, and the equations of asymptotes and the equations of axis of symmetry. So let's get started. Hyperbola is the graph of the form y is equals to a over x minus p plus q, right? So let's go ahead and talk about p, q, and a. Okay, let's start with q. Q is simply the horizontal asymptote of the graph. This graph has two asymptotes. Remember, asymptote is the line that the graph approaches but it never touches. So Q is going to be our horizontal asymptote, therefore it's like this. So we're gonna get y is equals to Q. So Q is going to be our horizontal asymptote. I'll show you on the graph. Then what about P? P is simply a vertical asymptote. So it's gonna give us the vertical asymptote like this. So we're going to represent asymptote with a dotted line like this. So here you're gonna get x is equals to p. Therefore this is gonna be our vertical asymptote and this one is our horizontal asymptote. Okay, let's go ahead and talk about letter A. So I'm not gonna talk much about letter A. Actually, all we have to know about letter A is that it's going to give you the quadrant or the shape of the graph. So whenever A is greater than 0, so our graph is going to be in this form. It's more like in the first quadrant and the third quadrant, right? So these dotted lines represent our asymptotes, right? So when A is less than 0, and we know anything that is less than 0 is negative. That means when A is negative, the shape of our graph will be on this form. It's more like in the second and the fourth quadrant, right? Okay, let's go ahead and draw a parabola graph. Let's say we have the graph that looks like this. A is equals to x minus 2 plus 3. So go ahead and draw this graph as well as finding the range, domain, axis of symmetry, etc. So when I draw the graph of hyperbola, follow simple steps. The first step is to identify your asymptotes, right? And the second step is to find the intercept with the axis. Okay, let's go ahead and do the first step. The equations of asymptotes for this graph is going to be, let me write the asymptotes here for clarity. So remember, we have two asymptotes, the horizontal asymptote and the vertical asymptote. So let's go ahead and write the horizontal asymptote. Horizontal asymptote is given by 3. Remember, Q represents asymptote. So on this case, our Q is 3. So it's going to be equals to 3. This is our horizontal asymptote. So now I want the vertical asymptote. Whenever I want the vertical asymptote, I'm going to equate this thing on the denominator to 0. So it's going to be x minus 2 is equals to 0. Then let me go ahead and solve for x. Therefore x is equals to 2. Therefore I transpose negative 2 to the other side. This changes the sign to positive. Now I got the asymptote. Let me go ahead and find the y-intercept. Since this is the easiest. Remember, when you find the y-intercept, you get x is equals to 0, right? Perfect. So in our equation, when I see x, I'm going to write 0 minus 2 plus 3. If we can go ahead and press the calculator. Let's see what we get on a calculator. So 1 over 0 minus 2 plus 3 which is equals to 5 over 2. Please leave it as a fraction, right? And let's go ahead and find the x-intercept. Let y is equals to 0. just squeeze it here. So when I see where I'm going to replace it with 0, I'll substitute it with 0. X minus 2 plus 3. So in this case, I'm going to transpose 3 to the other side. It's going to be negative. Now I can cross multiply here to find the value of x. It's going to be negative 3. Remember, whenever you have a fraction and equation between, you cross multiply, right? It's a basic mathematics. So this one you have to put it inside a bracket because you're multiplying two terms. So we're going to distribute this negative 3 to become negative 3x. Negative 3 multiplied by negative 2 is positive 6. Right? Let's go ahead and solve for x. Transpose 6 to the other side, it becomes negative. So it's going to be 1 minus 6, which is negative 5. Then we divide both sides by negative 3. X is going to be 5 over 3. Now we got our intercept. 5 over 3 into 0. Now let's go ahead and draw the graph. We need another page. So when you draw the graph, you don't even need a ruler. All you have to show is the correct level of your main point. Perfect. I'll start by drawing the asymptotes. Remember, our asymptote is y is equals to 3. So is equals to 3 and x is equals to negative. Okay, sorry, so is equals to 3 and x is equals to 2. So y is equals to 3 somewhere here, right? So just go ahead and make a horizontal asymptote. Then x is equals to 2. So x is equals to 2 somewhere here. It's positive, right? So just make a vertical asymptote. Now I'm done with the asymptotes. I have to label them. This is y is equals to 3. This is x is equals to 2. Let me go ahead and plot the x-intercept and y-intercept. Y-intercept is where y is equals to 5 over 2 is 0 to 5 over 2. 5 over 2 is approximately 2,5. So 2,5 is between 0 and 3. So it's somewhere here. To label it, this is 5 over 2. Then x-intercept is 5 over 3. 5 over 3 is about 1,66, which is somewhere here between 0 and 2. We have to label it 2 is 5 over 3. Now we can simply join the points and draw the graph. So the other half will be that side. Remember, a is greater than 0 here because a is equals to 1 and a is positive. So when a is positive, the graph will look like this. So this one makes a lot of sense, right? So let's go ahead and talk about range and domain. So range and domain for hyperbola is very easy to remember, right? It's domain. So I usually use this short reminder for myself, docs. Whenever I talk about domain, I look at the x values. Whenever I talk about the range, I look at the y values, right? So here's the range. So for range, I'm going to look at the y values. But when we look at this graph exists everywhere because this graph for the y values is gonna be, remember, this are the y values and this are the x values. So this graph will go downwards forever, right? For all the negative values downwards, and it will go up here for all the positive y values, right? But on this line, it doesn't exist. It's gonna exist everywhere except at this line. Everywhere upward and everywhere downwards, the graph exists for the y values except at this line. So The range for this graph will be where is an element of real number, where y is not equals to 3. Remember on this line doesn't exist when y is equals to 3, right? The same applies with domain is x is an element of real number, but for the x values it doesn't exist where x is equals to 2. Therefore it will be where x is not equals to 2. Perfect. Now let me talk about the last thing about hyperbola. So hyperbola, it has the axis of symmetry. It has the axis of symmetry. Axis of symmetry, they divide graph in between equally. So the first one will pass like this through the intersection of the asymptotes, right? So this one is going to be the positive axis of symmetry. Eccentricity, that is going to be x plus c, and the other one will be like this. It will also pass through the intersection of the asymptotes. So this one will be y is equals to negative x plus c. This one is going to have negative gradient, right, because it's decreasing. So our task is to find the value of c. So let's go ahead and find the equations of the axis of symmetry for the positive gradient. So for positive gradient is going to be x plus c. The gradient is always 1, so it's going to be positive 1, right? So what about y and x? Since these two graphs they pass through the intersection of the asymptotes, for y and x we are going to use the asymptote always. So what was the y value of the asymptote is going to be 3. Basically is this point here where they intersect. This point, its x value is 2 and its y value is 3 at this intersection. So this graph they pass through this point, therefore we're going to use that point. So y is equals to 3, x is equals to 2. Then I solve for c, I take 2 this side. 3 minus 2 is 1. Therefore the equation is going to be x plus c is 1. So I got axis of symmetry with a positive gradient. Let's go ahead and do the same for negative gradient. So it's going to be y is equals to negative x plus c. Y they pass through the same point, therefore I'm still going to use the same point. Our asymptote y is 3, x is 2, is negative. Don't forget this negative sign here. Therefore it's going to be, this is negative multiplied by 2 is negative 2, so I take it this side comes positive. So 3 plus 2 is going to be 5. Therefore this is going to be negative x plus 5. Then we just got the axis of symmetry. Because this is the rough sketch, it's going to pass, this line is actually going to pass somewhere here where x is equals to 1, not where x is equals to 0. So that's it for hyperbola. That is all you need to know.